Hello, this is Patty Mantilla, and I'm here today to speak with you about body composition, and more specifically about the methods to assess body composition and how to do those calculations so that you can provide your client with an accurate assessment of fat-free versus fat mass, or the ratio of lean to fat. Body composition may be assessed several ways. The first of which is hydrostatic or underwater weighing. Dual X-ray absorptometry, or DEXA, is another highly accurate method similar to hydrostatic weighing. The bod pod, which looks like a giant egg that you sit in, is a good measurement of body fat because it measures air pressure changes as a result of your level of body fatness. These top three methods, hydrostatic weighing, DEXA, and bod pod, however, are not frequently found in the health club setting, and so we often have to rely on skin fold calipers, BMI, waist-hip ratios, and circumference measurements. There are two formulas to calculate BMI. The first is using the metric system, and that is weight in kilograms divided by height in meters squared. To do that, of course, we first have to convert our weight in pounds to kilograms and our height in feet and inches into meters, and then square that. To convert the weight, we would either multiply the body weight in pounds by 0.45 or divide the body weight in pounds by 2.2. And it comes out very close one to the other, not exact, but very close. I prefer the multiplication because I can see it in my brain. You know, if somebody's 180 pounds, slightly less than half of that is their kilogram weight. But either method is fine. To calculate the height in meters squared, you need to first convert your height from feet and inches to inches, and then divide the inches by 39 to get meters, because there are 39 inches in 1 meter. And then, of course, you square that. And the last step is divide the weight by the height. The goal is to have an ideal or normal body of BMI somewhere between 18.5 and 24.9. Under 18.5 would be underweight. Greater than 25 up to 29.9 would be considered overweight. And 30 and above begins the obesity continuum. We know that's where the health risks for diseases such as heart disease, pulmonary diseases, diabetes occur. Let's look at an example. Using the metric system first, we have an individual who's 5 feet 10 inches and 190 pounds. So our first step is convert this pound weight to kilograms. If we multiply it by 0.45, 190 by 0.45, we come out with 85.5, but rounded up brings us to 86. If we use the divide by 2.2 to convert the pound weight to kilograms, 190 by 2.2 is 86.36, or rounded down, it would become 86. So either way, we come up with a weight at 86. To calculate the height in meters squared, we're going to take that 5'10", 5 feet is 60 inches, plus 10 equals 70 inches. Divide that by 39 to get meters, and then, of course, square that. So 70 inches divided by 39 brings us to 1.8 meters, rounded up slightly. If you square that or multiply it by itself, you get 3.24. So we have our kilogram weight of 86 divided by our height in meters squared of 3.24. That brings us to 26.54 kilograms per meter squared, or if we round that up, it's 27. Using the American system, we would take our body weight in pounds, multiply that by 703, and then divide it by height in inches. So once again, let's take that 190, the body weight, times 703, gives us 133,570, a very large number. Then we're going to take the height from feet in inches and bring it to inches. So 5 feet is 60 inches plus 10 is 70 inches, but squared, that equals 4,900. Now our final step is to divide the body weight by the height, and we come up with 27.26, or rounded down gives us 27. So either method, whether using the metric or the American system, we're going to come up with a BMI of 27, which puts this client in a slightly overweight category. Another method we can use is waist-hip ratios. This is very, very easy. Measure the waist in the smallest point. Measure the hips at the widest point just above the gluteal fold. And then divide the waist by the hip. Ideally, a man's waist should be smaller than his hips, or it should be 95% or less, or about a 1-to-1 ratio. And ideally, a woman's waist should be smaller than her hips, or a ratio of 0.8 to 1 or under 0.86 would be desirable. So let's take a look at that. Let's say we have a male who has a waist of 39 inches and hips of 40. 39 divided by 40 equals 0.975, or rounded up 0.98. There should be a point there. So remember, we said that ideally a man should be under 0.95, so we know that this would put this man slightly over the desired range. For a female, remember the waist should be smaller than the hip. We have a waist of 38 and hips of 37, so right away we know, okay, she's not meeting the recommended range. But if we divide it out, the waist by the hip, we come out with 1.027, and the female should be under 0.86, or a waist-hip ratio of 0.8 to 1. So we know she's slightly over the desired range. And some adjustments in caloric intake and expenditure would likely rectify that problem. So another method that's just so easy to do is measuring waist circumference. All you need is a tape measure. Measure the waist at the most narrow point. Men who are at low risk would be under 31.5 inches or under 80 centimeters. And at risk would be greater than or equal to 40 inches or greater than or equal to 102. Females in the low risk category would have a waist circumference of 27.5 inches or less, or less than 70 centimeters. And an at-risk female would be equal to or greater than 35 inches or equal to or greater than 88 centimeters. So it's one measurement, look at the norms, and you're good to go. Here's the hard part, convincing people that they can lose that body fat and that it's simply a caloric balance equation. If you want to lose body fat, you need to reduce the calories and or increase the caloric expenditure. Eat less, work out more. To lose 1 pound, you have to eliminate either through decreased dietary intake or increased energy expenditure by 3,500 calories. To lose 1 pound a week, that means you'd have to eliminate 500 calories per day. So for the average person, that might be skip the glass of wine or the ice cream and walk an extra half hour every day, briskly. Something of that nature. To lose 2 pounds a week, you'd have to eliminate 1,000 calories per day. So that would be a little more challenging. Maybe you have to eliminate all the snackies in the day and work out for an extra hour, or a harder workout for a half hour. It's certainly quite possible to do. It's just an energy balance. You can also teach your clients Portion control. There are some great pictures out there of what one portion looks like, or great handouts you can provide them. And also teach them how to read food labels. How to read a food label. First, look at the serving size. You've got to be honest here, right? That box of macaroni and cheese is probably 4 servings, not 1. Then you look at the grams of each nutrient. Remember, 1 gram of fat has 9 kilocalories. A gram of protein and carbohydrates each have 4. And alcohol, by the way, is 7 kilocalories of non-nutrient dense energy. So to calculate the percentage of each nutrient, you would look at the number of grams times the number of calories and then divide that by the total calories. So let's take a look at an example. Remember, your first step is to look at what is the serving size and how many per container. Then you're going to check the calories total. This is again per serving. Calories from fat are often provided here for you, and right away you can see almost half are coming from fat. But if you read the fat label, it looks like, oh, this is about 18% fat. No, that's 18% of the daily value of what you need in a day. That's not 18% of this product is fat. So we'd have to take the 12 grams of fat times 9, and that would tell you how many calories, and then divide that by the total calories. We'll get back to that. Carbohydrates, you see 31 grams at 4 calories each. Protein, 5 grams at 4 calories each. So to calculate the fat content of this macaroni and cheese, we saw that there were 12 grams of fat. Each gram has 9 kilocalories. 12 times 9 is 108 calories from fat. Now they rounded up a little bit, and that's okay as long as it's within a certain margin. But if 108 out of 250 calories come from fat, then we're looking at about 43% fat. Is this a horrific choice? No, but it's certainly not your healthiest choice. So now it would come down to how often do you do this and how much do you eat when you have macaroni and cheese. If you have 2 boxes, then maybe that is a problem. But if you occasionally have a serving of that and it can fit in your lifestyle, that's probably fine. Here's a common one that really fools people. 2% milk. Right away you think, well, that's probably 2% fat. No, if you look at the calories per serving is 120. Calories from fat is 45. So in my little math brain, right away I can see that's about a third. A little more than a third. But let's do the math. If there are 5 grams of fat, here we are, 5 grams at 9 calories each, that's 45 kilocalories from fat out of 120. When you divide it out, it's 37.5, or rounded up, 38% fat in this 2% milk. We can also calculate other labels. Let's take a look at this McDonald's double cheeseburger. Starting with the fat, we see 23 grams of fat at 9 kilocalories each. Brings us to 207 calories from fat out of 440 total. So it's about 47% fat. They make it look like it's 35, but our calculations tell us it's 47%. You can do the same with protein and carbs. Remember, 1 gram of protein has 4 kilocalories. Well, this product has 25 grams, so 100 calories of that 440 brings us to 23% protein. If we look at carbohydrates, 34 grams times 4 is 136 kilocalories from carbohydrates out of 440. So about 31% of this burger comes from carbohydrates. Great food choice, not on a daily basis for sure. An occasional burger, probably okay. Nutrient recommendations, about 60%. And you'll see a variety of numbers between 45 and 60% of the daily intake, or 6 to 10 grams per kilogram of body weight. Protein for the non-athlete should be about 10 to 35% of the intake, or 0.8 grams per kilogram of body weight. And for the athlete, a little higher, 1.2 to 1.7, depending upon if your endurance or strength. Fat should be about 20 to 35% of the dietary intake. So let's take a look at this. If carbs should be about 60% of your intake and the average diet is 2,000 calories, 60% of 2,000 is about 1,200 kilocalories from carbs. To convert that to grams, you divide it by 4. Excuse me, because we know there are 4 calories in 1 gram of carbohydrates. If you want to calculate this based on a body weight, 6 grams per kilogram, this 6 grams times 90 kilograms, this would be a 200-pound person, would be 540 grams, or multiply that by 4 to figure out how many kilocalories of carbs that person should be taking. And you could do the same thing by 10 grams to get the high end of that range. Protein intake, 0.8 grams times 90 kilograms for a 200-pound person. In this case, we're talking non-athlete. Would equate to 72 grams daily, or 288 kilocalories when you multiply that gram weight by 4, because there's 4 calories per gram. For the athlete, we're going to go as low as 1.2 grams per kilogram. So 1.2 grams times 90 is 108 grams. Or to get calories, you'd have to multiply that by 4. In the high end, we do the same thing. 1.7 times the body weight in kilograms brings us to 153 grams. But to convert that to calories, you multiply it by 4. So 612 kilocalories from protein. Fat should be less than or equal to 20 to 35% of the daily intake. At the low end, if you're talking an average 2,000 calorie diet, 20% of 2,000 calories would be 400 calories. But if we want to convert that to grams, we'd have to divide that by 9, because there are 9 calories per gram. And that would bring us to 44.44 grams for this 200-pound person. The high end, or 35% of the 2,000 calorie a day diet, would be 700 kilocalories. But again, if you want to convert that to grams, you have to divide that by 9, which would take us to 77.78, or rounded up, 78 grams of fats. And however you calculate it, it should come up to, when you add the number of fat grams and protein grams and carbohydrate grams or kilocalories, when you put it all together, those should come up to be about 100%. So in other words, if we have 60% from carbohydrates, 20% fat, and 20% protein, that gives us 100. When you do those calculations, it should add up. They are allowed a slight margin of error, but it should be right around there. And again, I hope that this was helpful to you in doing your calculations, and good luck with your clients. I'll meet you in the next video. Thank you.